The final section in Chapter 6a is 6.3, Trigonometric Functions of Any Angle. If you recall from yesterday, when we plugged in trig values on our calculator, some of our answers were positive and some of our answers were negative. But when we've drawn triangles, our answers have only been positive. Today, we'll go into more detail about why negative answers exist with these trig definitions. My hope is that you definitely listen to this lesson as well as take detailed notes. Here we go. When we've drawn our right triangles and labeled side lengths, we did Pythagorean theorem to find the missing side. What was unique about our triangles in the past is that we've never actually put them in different quadrants, therefore all of our side lengths were positive. So all 6 of our trig definitions were also positive. But if we combine drawing triangles with finding angle locations in both degree and radian form, like we did in 6.1, we know that we can end up in any one of our 4 quadrants on the coordinate system. Because of that, certain x and y values actually change to negative, which will then alter your trig definition. Notice it says let theta be an angle in standard position with xy a point on the terminal side of theta, and r is found by taking the square root of x squared plus y squared. This is ultimately Pythagorean theorem, and r can't be 0. We now have 6 unique definitions for our trig functions on a coordinate system that truly match up with our SOHCAHTOA rules. Here's what I mean. Sine theta, it says, is now defined as y over r. So on our picture, we're going to end up creating a triangle, and we will do a little Pythagorean theorem. Y over r will ultimately mean opposite over hypotenuse. We're just using a new definition with these values on the coordinate system. Cosine is x over r, which will ultimately be adjacent over hypotenuse. But the answers for these could be positive or negative depending on where x and y are located on the coordinate system. One thing to note in this definition, please add this in. R will always be positive. If you have to do Pythagorean theorem to find the value of that hypotenuse or the r, just recognize that that answer will never have a negative option. The hypotenuse is always positive. Over to the right, we're going to look at some more key things to recognize in these types of examples. When we draw our pictures, the location of the terminal ray matters. It will help you determine the coordinate you're in, or the quadrant you're in. You always want to connect the ray that you've created down to the x-axis, and then you'll create a triangle. And your triangle will be a right triangle. That will help you determine all of your trig definitions. Typically, when we've graphed, we've always had our values that are essentially in quadrant 1, meaning your x and your y, your side lengths are always positive, so is the hypotenuse. Therefore, all 6 trig definitions are positive. Again, in quadrant 1, you know all of your trig definitions are positive because both x and y have positive values. But if your angle moves you into quadrant 2 in some way, now your ordered pair is going to give you different types of trig definitions. In quadrant 2, your x value is actually negative and your y value is positive. That means both cosine and tangent and secant and cotangent are going to have negative answers because of quadrant 2. Sine, definition is y over r, and cosecant would both be positive since the x or the y coordinate is positive in quadrant 2. If your angle moves you down into quadrant 3, think about your x and y values if you are plotting a coordinate in that location. Both x and y are negative, which would mean sine and cosine, cosecant and secant, will also have negative answers. The only positive answers you'll get for trig functions in quadrant 3 are tangent and cotangent. Last but not least, quadrant 4, if you have a coordinate that puts you into quadrant 4, now your x value is positive, but the y value is negative to drop it down into that quadrant. That means cosine and secant are the only values that are positive, but sine, cosecant, tangent, and cotangent will all be negative. Over to the left, let's take a look at an example to see if we can put this to practice. If sine theta equals 4/5 and tangent of theta is less than 0, Find cosine and cotangent. The first part of the question will tell us where to draw our picture. The second part's asking us to find specific values. If sine theta is equal to 4/5, that's a positive answer for sine, so that's positive. If tan theta is less than 0, answers that are less than 0 are negative answers. Our first goal is to determine where are we drawing this picture. Let's start by creating a coordinate system over here on the left. We're just going to draw a big coordinate system. Now it says sine is a positive answer. So using that quadrant chart on the right, sine is positive in quadrants 1 and 2. So far, those are the two choices where we can create our triangle. But then notice it says tangent is negative. And using that quadrant chart, tangent has negative values in quadrant 2 and then down in quadrant 4. The quadrant where both statements are true then is quadrant 2. That's where we'll draw our triangle. To make that work, what you want to do is start at the center. And we'll draw our R value, that was hard to say, somewhere out into quadrant 2, which is also the hypotenuse of the triangle. And then it says always connect that ray down to the x-axis. That's how you want to create your right triangle. The angle that connects from the center of the coordinate system out to the edge, and then drop your line down to the x-axis to create the right angle. Now your theta, or your reference angle, is always in the corner at the center of the coordinate system. So I'm going to put theta there. I'm going to give myself a little bit more room over here on this left-hand side. There we go. And then take a look at the sine definition. Remember, sine is y over r, or opposite over hypotenuse. So the y value is that vertical segment. The r value is, or the 5 is the r, or the hypotenuse. All right, so then it says find cosine and cotangent. To get those answers, we actually need the value of x down below. And we'll do Pythagorean theorem. But here's where Pythagorean theorem will look slightly different than what we've done so far in this chapter. When we apply a squared plus b squared equals c squared, we're all good with that, I hope. I'm going to let a be that horizontal length, my x squared. B would equal 4 squared. C is always the hypotenuse, or in this case our r value, which is 5 squared. Many of you may already recognize what our answer is, but I want you to go through this anyway. If we square 4, we get 16, and 5, we get 25. Move 16 over, so nothing new yet. We get x squared equals 9. We've done this before. Take the square root of 9, but here's where I want you to note what's unique about this problem. Put a little star right there to make that stand out. When you take the square root and we're recognizing values in any one of the 4 quadrants, we have to actually remember that the square root of 9 has 2 possible values, positive or negative 3. So put a little question mark right there. If x could be positive 3 or negative 3, which value of x is meaningful in quadrant 2? If you're counting to the left, even though we know length by definition is a positive answer, we're going in a negative direction. So in this case, x actually equals negative 3. And that represents the direction on that left-hand side. So that's something that will be unique to these pictures that we haven't had yet in the past. That being said, we've got our picture. Now we can identify cosine and cotangent. The definition for cosine on our coordinate system is x over r, which is adjacent over hypotenuse. Recognizing in quadrant 2, cosine is negative, we get that negative answer because x is negative in quadrant 2. The r value is positive 5. Therefore, cosine theta equals negative 3/5. Cotangent, same idea. Cotangent, by definition, is x over y. And in quadrant 2, cotangent's negative because we have negative 3 over 4. And that's how definitions will be either positive or negative. It all depends on location. Here's another way to interpret those definitions. Let -3, -7 be a point on the terminal side of theta in standard position. Find the exact values of the 6 trigonometric functions of the angle. If our ordered pair is -3, -7, both x and y are negative. Can you determine what quadrant that should be located in? It should be quadrant 3. Just like our example up above, you're going to want to show that in a coordinate system. I'm going to draw my coordinate system, but I'm going to kind of give myself some additional space over here in quadrant 3, since I know that's where I'm counting. Notice x is -3, so I'm going to count 3 to the left, and y is -7. So I got to make that fit. 1, 2, 3, 4, 5, 6, all the way down here to 7. What I'm going to do then is draw from the center of my graph all the way down to where -3, 7 would meet. So I'm going to put my point right there. This is on the terminal side of theta in standard position. That's what that first part means. Now remember, up above it says always connect this ray back up to the x-axis, and form your right triangle. So that's what we have there. We know that the length from the center of the graph out to that edge is 3 units, but in a negative direction. And then we're also counting down to get to that point at the bottom, so that's -7. Our theta value in standard position always puts us in the corner, connecting us to the center of the coordinate system. Using this information, the first thing we need to do is figure out the value of r, or the hypotenuse of our triangle. And again, we default to Pythagorean theorem, like so. We know our x and our y are the a and the b values, the two sides that create the right angle. So this is where you may want a calculator. All right, -3 squared is actually +9. -7 squared is actually +49. So make sure if you're typing those into your calculator to check that you put them in parentheses. 9 plus 49 is 58. Ooh, that's kind of a bummer. That's not a perfect square. So when we take the square root, remember for the hypotenuse, it's always a positive value. So we're just going to keep that positive 58. So always positive. Like so. Let's go ahead and label that side length square root 58 and determine our 6 trigonometric functions. We know we'll start off with sine, so I have sine theta. Remember the definition up above, sine theta is y divided by r. The y value is -7, so our answer is going to be negative. And then the r value is square root 58. So we should recognize what to do here. We have to rationalize the denominator. I'll multiply top and bottom by square root 58 over square root 58. And what that allows us to do is just move that square root out of the denominator. In the numerator, we still have it, -7 square root 58 over 58. That's quite a fraction answer for sine theta in quadrant 3. Let's try cosine. Same thing happens. We have x over r. X is -3, and then we have that square root 58. So if you recognize that with that square root in the denominator, we can just put it as a product in the numerator with the number, and then plain 58 in the denominator, you don't have to show the rationalized step. So if you can go from that step to the answer, I'm good with that. Otherwise, rationalize it, just show that process. Remember, there are only going to be 2 numbers or 2 values that need to be rationalized. So we've got them both done. Let's determine tangent. Tangent of theta is y over x. One thing to note here, y is -7 and x is -3. Anytime you have 2 negatives, simplify your fraction. It becomes positive 7/3. Look at that. I'm already out of space. Imagine that. All right, I'm going to slide over. I really am out of space. Hang on. I'm going to zoom this out a little bit. Ooh, the magic of the cinema. All right, let's do the reciprocal functions. Those will go pretty quick. The reciprocal of sine is cosecant. So hopefully you have some room to get this to fit. These will fit. They should fit pretty nicely. We've got some space. Cosecant is r over y, and that's just square root 58 over -7. So the square root's already in the numerator. Excellent. The reciprocal of cosine is secant, and that's r over x. That becomes square root 58 over negative 3. That's a 3 right there. Make sure you guys can see that. Sorry. I want to make sure that's clear. That's better. All right. And then the reciprocal of tangent is cotangent. That's x over y. And we can just take the reciprocal of our answer for tangent, positive 3/7. So there you go. There's the 6 trig definitions by plotting a coordinate in standard position. I was going to continue on, but I think that's enough for today. So we will finish our notes tomorrow in class.